Hey, welcome to The Explainer. Today we're going to take what looks like a super technical guide and turn it into your personal roadmap for building a deep learning model. We'll break down the entire process from picking the right blueprint all the way to choosing the perfect tools for the job. Okay, so you've decided you're going to build an AI model. Awesome, but where do you even start, right? It can feel like you're standing at the bottom of a giant skyscraper with just a hammer. It's a lot. That's why we're going to frame this whole thing as the builder's journey, a step-by-step guide to get you from the foundation all the way to the top floor. Let's start with the most important document for any construction project.
All right, first things first. Every single great building starts with a blueprint. In AI, we just call it the model architecture. And picking the right one, well, that choice almost always comes down to answering one simple question about your data.
So what are you working with? Is it images, where it's all about how pixels are arranged in space, or is it text, where the order of the words is what gives it meaning? That one decision right there is going to steer the rest of your project. So if your project is all about seeing things, like classifying photos or spotting objects in a video, then your go-to blueprint is, hands down, the Convolutional Neural Network, or CNN. Just think of it like a specialist that's trained to spot patterns, edges, shapes, textures, kind of like how our own eyes work.
But what if it's not about space, but about time or order? You know, like translating a sentence or even predicting stock prices. For that, you need an architect that has a memory. And that, my friends, is the Recurrent Neural Network, or RNN. It reads things one by one, remembering what it just saw to understand the bigger picture.
Okay, now this slide, this is basically your master cheat sheet. It lays out all the main blueprints, going way beyond just CNNs and RNNs. You need to analyze a whole book? That's an LSTM. You want to create brand new, realistic images? That's a job for a GAN. And here's a pro tip. If you barely have any data to work with, transfer learning is your secret weapon.
All right, we've got our blueprint. Now it's time to open up the toolbox. We need to pick our power tools. Those are the software frameworks. And we need a serious engine to make them run.
So in your toolkit, you're going to find these three big names. You've got TensorFlow, that's your industrial strength tool, perfect for when you're ready to go into production. Then there's PyTorch, which is a total favorite among researchers because it's so flexible. And if you're just starting out, Keras is your best friend, super easy to learn.
So why do we even care so much about the engine? Well, training one of these models involves a ridiculous amount of math, all happening at once. A normal CPU, it's like a master carpenter, amazing at doing one complicated thing at a time. A GPU, on the other hand, is like a whole factory floor full of workers, all doing thousands of simple calculations at the exact same time. We're talking the difference between your model training in a few hours versus a few weeks. It's a no-brainer.
And here's the last piece of the puzzle that connects everything. Your software, like TensorFlow, needs a way to talk to that powerful GPU engine. That's where CUDA comes in. Just think of it as a special adapter made by NVIDIA that lets your code tap into all that massive power from their GPUs. Oh, and hey, quick tip for anyone out there studying for a certification. You might see an older framework called Caffe 2 pop up on an exam. If you do, just remember this one thing. Caffe 2 and Linux, specifically Ubuntu, they go together. It's a super common association they'd love to test you on. Okay, so our blueprint is picked out, the toolbox is ready to go. But hey, even the best builders run into snacks. So let's talk about one of the most common problems you'll face in AI, something called overfitting. So what exactly is overfitting? Imagine a student who crams for a test, but instead of learning the material, they just memorize the answers on the practice sheet. They'll get 100% on the practice test for sure, but the second the real exam asks a slightly different question, they're toast. That's exactly what your model is doing. It's memorized the training data instead of actually learning the rules. The good news is we have a whole bag of tricks to fix this. You can use data augmentation to basically create more practice questions. You can use regularization to penalize the model for being too complex. You can use something called dropout, which forces it to be less reliant on any single piece of information. Or you could just use early stopping and, quit while you're ahead. These are your go-to fixes for sure.
All right, you've got the blueprints, you've got the tools, and you even have the troubleshooting guide. Let's run through a couple of quick scenarios just to make sure all this stuff really sticks.
Scenario 1. You're building a translator to go from English to French. Word order is everything. What's your blueprint? You got it. It has to be a recurrent neural network, an RNN. Translation is the classic example of a sequence-to-sequence problem, and RNNs were literally built to handle data where the order is the most important thing.
Okay, next up. Your image classifier is getting a perfect score on your training data, but it's totally bombing in the real world. It's memorizing. What do you do?
The smartest play here is a 1-2 punch. First, you hit it with regularization. That forces the model to simplify itself, to stop focusing on all the tiny, weird details. Then you use data augmentation to create a ton more training images. That makes it way harder for the model to just memorize everything.
And for our last one, you're setting up a new machine for deep learning. The number one requirement is that it has to run CUDA. What's the one piece of hardware you absolutely cannot do without?
Yep, you 100% need an NVIDIA GPU. CUDA is their software platform built to run on their hardware. They're a package deal. No GPU, no CUDA. Simple as that.
And there you have it. You've basically got the mental roadmap now to tackle a deep learning project. You know how to pick your blueprint, how to grab the right tools, and even how to fix the most common issues that pop up. The builder's journey is complete. So, the only question left is, what are you going to build first?